Okay, in this video I'm going to deal with surds at National 5 level. Well, surds are numbers left in a square root form. For example, root 2, that's a number left in a square root form, square root of 2, and that's called a surd because we can't write the answer to this in decimal format exactly. It goes on forever. So a surd is an irrational number, a number that can't be written exactly as a decimal. And for accuracy, when we're dealing with problems, quite often we need to be very accurate, which means that we have to use surds and have to be able to use them and apply them and learn the rules of operations. So in this video we're going to show you how to apply the rules, mostly simplifying answers. That's what surds at National 5 level are. You're given a bit of information and you're asked to simplify. You're also asked to rationalise the denominator, which we'll come on to in a wee minute. That type of idea. But what's the rules we have to know? Well, there's a few wee rules. Root A times root B is equal to the square root of AB. Use that an awful lot at National 5 when we're simplifying, and we have to be able to work both ways round. Okay, and from that there's a special case. Root A times root A is equal to A. And if you don't believe me with that, try it in a calculator. Pick a number for A and put that in your calculator and you'll see that it does equal A. So just a wee example for you. Say root 5 times root 5 is equal to 5. Okay. When we're tidying up surds, we can only tidy up ones that are the same. So for example, root 3 plus root 3, well, that's 2 root 3's, so that's 2 root 3. But if we have root 3 plus root 2, that is not root 5. We can't do anything with that. The answer to that is root 3 plus root 2. Okay, so that's quite an important concept as well, and when we come on to the questions. And to simplify surds, square numbers, it's all about square numbers. Okay, so think square numbers. Now square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and it goes on and on. Okay, so when we're tackling these questions, we're thinking square numbers and we're thinking these rules here. And just knowing that basic amount, we can tackle quite a few questions at National 5 level. So let's look at a couple that we can try. So I think the first one we'll attempt is rationalising. So let's look at this question here. Root 3 over root 24. And the question says rationalise the denominator. Now this is a fraction with surds in it, and the denominator is the bottom. Now rationalising the denominator means that you don't have any roots, you don't have this root sign in the bottom. So we have to get rid of that and then simplify it as much as we can. Now the easiest technique to use for this is multiplying top and bottom by root 24. Okay. Now when we do that, your rules for fractions, we multiply the top together, multiply the bottom together. Now when using this rule here, root A times root A is equal to A for the denominator. So that's going to give us, for the top, that multiplied together, root 72 over 24 using root 24 times root 24 is 24. Now, next step is think square numbers. What's a high square number that goes into 72? Well, you have to know your square numbers, 1, 4, 9, etc. Well, that'll be 36. Square root of 36, root 2 over 24. Now, we're thinking square numbers here, but we're also using this rule here, but in reverse. There's root 72, that's the same as root 36 times root 2. Well, why do we want to use square numbers? Because square numbers give us an exact value for the root. Root 36 is 6 over, 6 root 2 over 24. And we can now cancel down products and quotients, so only multiplication and division. So that's 6 into 6 goes once, 6 into 24 goes 4 times. So we have root 2 over 4. Now we can't go any further because the question says rationalise the denominator, which means that we don't have any roots in the bottom. Nothing else will cancel there. So that's your final answer. And that's usually worth about 3 marks in your exam. A nice question to come up. And it's only to do with these rules here. That's all we need to determine. We don't really need the root 2, we can get rid of that. I was just telling you what a root was. So, let's look at another question. Got root 27 plus 2 root 3. Now, this question it says simplify, which basically means tidy it up. So it can simplify it down, tidy it up. Now, to tidy things up, we have to have the same surd. So the surd here is 2 root 3, so we have to have root 3's. And if we have root 3's, then we can tidy them up. If they're different roots or different surds, we can't tidy them up. So we need to change this into root 3's if we can. Again, back to think square numbers and this rule here. So we can split root 27 into root 9, root 3, and the hints in the question, because we want to get root 3's. So we've thought square numbers and we're using this rule. So the square root of 9 is 3, so that's 3 root 3 plus 2 root 3. We can now tidy this up because it's the same roots that we have. So I've got 3 of them and I've got another 2 of them, so I'll have 5 of them, so I've got 5 root 3. Question finished. Again, 3 marks in the exam. It's a dead easy 3 marks once you get used to it. So let's look at something a wee bit harder. Next question is going to be broken into A, B and C. So first part of the question, it asks to simplify root 2, root 18. So we have to simplify that. Well, to simplify it, let's look at this rule here. Again, we're back to this rule. Well, root A times root B equals the square root of AB. Well, if we do that, that's 2 times 18, which is 36. That's root 36. The square root of 36 is 6. So, there we go. Nice and easy. Second part of the question. We have to simplify this. Root 2 plus root 18. Now let's add this time. Notice how we don't have any rules for adding really, but we can only add roots that are the same. So to tidy this up, we have to write root 18 in terms of root 2, and if we can do that, then we can tidy up the root 2's. So let's look at that. That's root 2 then, plus think square numbers. So we can split that into root 9, root 2. That gives me root 2. Well, the square root of 9 is 3, so that's 3, root 2. And then we can tidy that up. We've got one of them and another 3 of them, so we have 4 of them. So we have 4 root 2's. And the last part, it says show that root 2 times root 18 is equal to over root 2 plus root 18 is equal to 3 root 2 over 4. So to show that, well, we can use parts A and B here. The top part, well, we just said that was 6. We worked that out in part A. And part B is the bottom part of the fraction. That's 4 root 2. And we have to show it equals this thing here. Well, essentially we have to rationalise the denominator because we've got a root 2 here and we don't have any roots here. So let's multiply top and bottom here by root 2. And we use our fraction rules. That gives me 6 root 2 over, well, root 2 times root 2, well that's that rule here. Root A times root A is root A, sorry, root A times root A is A. So root 2 times root 2 is 2, 2 fours are 8. And now we can simplify 2 into 6 goes 3 times, 2 into 8 goes 4 times, which gives me 3 root 2 over 4, and that's what the question was asking me to do. So you can see that there's not very much to these problems. Let's try and work out, I'll give you a harder type one. The ones we've done so far are very routine, come up a lot. But here's one that involves a wee bit of algebra. Root x plus root 18 is to equal 4 root 2. So we have to work out what x is going to be such that if we add on root 18 we get 4 root 2. Well, it's just like an equation. We need to write root 18 in terms of root 2 if we can. So let's try that. So we have root x then is equal to, oh sorry, root x plus, splitting that into root 9 root 2 is equal to 4 root 2. Well, that's going to give me root x plus 3 root 2 is equal to 4 root 2. Now, it's just an equation, so let's subtract root 3 root 2 from both sides. So root x then is equal to, well, 4 root 2 to give me 3 root 2, just in the root 2. And you can see here that the root is there, the root's there, so the only difference, x must be equal to 2. And that's your answer. Okay, so that was us introducing a wee bit of algebra into Surds. Quite an uncommon, quite a unusual question. Don't see a lot of those type of questions come up in the exam. It's usually these type. Right, let's go back to root 24, root 2. Okay, these type of questions come up a lot. And we have to simplify that. Now, it doesn't say rationalise the denominator in this question, or the numerator, or anything like that, it just says simplify it. So, we just simplify it as much as we can, and that's our answer. So, we always look for square numbers if we can. Okay, so 24 square numbers, well that would be root 4 root 6 over root 2. Well, the square root of 4 is 2, so that's 2 root 6 over root 2. Now, we're going to go to this equation here, root a times root b is equal to root ab, and I'm going to use it in reverse, so I'm going to go that way. So I'm going to split up root 6 into root 3, root 2, all over root 2. And because it's products and quotients, i.e. multiplication and division, we can cancel down. So root 2 into root 2 goes once, root 2 into root 2 goes once, so we have 2 root 3 over 1, which is simply 2 root 3. And that's it, simplified as much as possible. A lot of people would leave it at that point there. You get some marks, but it can go a wee bit further, you can simplify it a wee bit more. Okay, but we've only learned 3 rules there, and that's helped us to do practically every question that we've done so far. Here's another one. We have to simplify 2 root 75. Square numbers again. So 2 root 25 root 3. That's me splitting 75 into 25 times 3. Square root of 25 is 5, so that's 5 2s. 5 2s are 10. 10 root 3. I think that question would only be worth 2 marks. That's a very simple question. So let's look at one that we have to sort of tidy up. So 2 root 20 minus 3 root 5. So remember our technique, we can only tidy up if we have the same root. Now that's root 20, that's root 5, so they're not the same. So we can't do anything with that unless we can write root 20 in terms of root 5s. Back to square numbers. How can we write root 20 in terms of square numbers? Well, we can write it as 2 root 4 root 5. So we split root 20 into that, minus 3 root 5. So these questions, when you're asked to simplify and tidy up, then look for the biggest root, look for the smallest root, and you're always trying to get the big root in terms of the smaller root. So the square root of 4 is 2, 2 2s are 4, so that's 4 root 5, minus 3 root 5. So I've got 4 of them, take away 3 of them, I'm left with 1 of them, so it's 1 root 5, or just root 5. Other questions we can get, well, we can get questions sometimes that involve Pythagoras and things like that, so I'll show you Pythagoras type questions for roots. So this would be deemed one of the harder type questions. You see all the questions we've done so far, pretty routine, pretty straightforward. So this question here, it's all to do with Pythagoras, and the question is essentially asking us to calculate the length of AC. So this is this side here, we'll just call it x. So to calculate the length of x, and we have to leave it as a surd in its simplest form. Well, it's Pythagoras, so we should know what Pythagoras is. The two shorter sides squared and added together equals the longest side squared. So from that, x squared plus root 32 squared is equal to root 50 squared. So we're back to that rule there. So root 32 times root 32, well, that's going to give me 32, and root 50 times root 50 is just 50. So I'm now left with subtracting 32 from both sides. X squared then is equal to 18. Therefore, take the square root of both sides, so x is equal to the square root of 18. But we have to simplify it as much as possible. Well, back to square numbers. Square root of 9, square root of 2, square root of 9 is 3, so it's 3 root 2. So the length of that side AC is 3 root 2. So that was Surds. in relation to Pythagoras, two topics at National 5, a good question because it deals with two topics. Quite like that question. Okay, so that's basically it for Surds. I'll do one more question. We'll do one more Pythagoras type question while we're here. So let's mix up the triangle a wee bit. So it's on its side. Maybe makes it a wee bit awkward for some people because it's not upright. Well, I'll make that C, I think. I'll make that A. And we'll say that's 8 centimetres. And we'll say that's 4 centimetres. And we'll call that X. So I have to find the length of BC. So again, looking at Pythagoras, finding our shorter side. So short side squared, this side squared is equal to the longer side squared minus the other shorter side squared. So that gives me x squared then is equal to 64 minus 16. So that's going to give me x squared then is equal to, if I take 14 away and then that 2, that would be 48. So taking the square root of both sides, so x is equal to the square root of 48. So can we simplify that? Well, we're going to have to look for square numbers. So we can split that up into root 16, root 3. Square root of 16 is 4, so it's 4 root 3. So the length of x, which is BC, is 4 root 3. I think that's enough. You see, there's no very many rules to be able to remember. Square numbers, very, very important. Helps us to simplify. Remember, we can only simplify if we have the same roots. We can gather things there. And you have to know what rationalising the denominator or the numerator means. It simply means don't have a root. If I say to you, rationalise the denominator, you can't have a root in the bottom. If I say to you, rationalise the numerator, that's the top of the fraction, you're not allowed to have a root in the top of the fraction. Okay? If you want more practice on this, go to mastervision.com, National 5, look down for surds and indices, and you'll see plenty of practice in there.